I want to work through an example now of how we can use triple integrals to find the volume of an enclosed solid. In this case, a solid bounded by these surfaces, y equals 2 minus z squared, y equals z squared, x plus z equals 4, and x equals 0. Now, I think first of all, what I want to do, I just want to look at notice I've got y equals 2 minus z squared and y equals z squared together. So let me just kind of take a look at those two solids, and what I'm doing is I'm assuming that x is 0. So I'm just going to look down here at the y, or the zy axis. Okay, so there's z and y. Now y equals z squared. Well, that would look like this, just be a parabola. Okay. Now remember, we're just assuming that x is coming out from this vertex, or this origin right here. X is coming out of the graph. And so this is y equals z squared. And then up here, we've got, we've got y equals 2 minus z squared. And that's what this is. And up here, of course, that's 2. So this is like an upside down parabola. We're more familiar when we have something like, we're graphing y equals x squared, y equals 2 minus x squared, but you changing your orientation a little bit, this is what we have. So when x is 0, this is what we're looking at. This is the zy plane here. Now, if you look at, well, what's happening? Okay, so this is down on the zy plane. Now, looking at this gives me an idea that maybe my first two integrals are going to deal with the zy plane. But I've got a third integral, and I'm thinking I'm going to integrate with respect to x first. Now, let's take a look at the graph. Let's see what we've got here. If you look at the graph, here's what it looks like. Now, this part that we're looking at here, you can see the zy plane. That's what's enclosed here, this little enclosed part. Now I'm going to rotate the graph a little bit. Let me see if I can flip it over. There we go. Okay. Now, just changing the orientation a little bit, you notice we've got this plane here. This plane cuts down through that. See, we've got the YZ plane here, and then we've got this plane cuts down through it. See, the plane cuts down, and what we're going to think about is if I pick any point. Let's go back here. If I pick any point in here, any x, any y, any z, what does the x do? Well, the x is going to go from 0 to that plane. Think about it. Starting here and coming out of the paper here, hitting that plane, we go from 0 to that plane. In other words, look, this is x is equal to 4 minus z. This is a straight shot here, 4 minus z. So I'm going to integrate with respect to x first, because that seems like it's going to be the simplest. One clue was they gave us this business here that they seem to be asking us, okay, the last two integrals, look on the zy plane. Okay? And realize no matter which point I choose in here, the x is going to go from 0 to that plane. It's going to hit that plane that slopes downward. So I'm going to integrate with respect to x first. Then, next I have to choose, okay, what do I want to integrate with respect to next? I think I'll choose y. Because notice y goes from z squared, okay? No matter what y I choose, okay, or what z I choose, y is going to go from z squared to 2 minus z squared. No matter what z, here's what y does. Y goes from here up to here. So I'm going to go from z squared to 2 minus z squared. Okay, and then of course the last thing I do, only thing that's left is the integrating with respect to z. Now, z is going to go from here to here. Okay. And what is that? Well, let's find out what those intersections are. We've got 2 minus z squared equals z squared. That's 2z squared equals 2, or, z squared equals 1. So z is equal to plus or minus 1. Okay? So here we go. We go from negative 1 to 1. Now we've got our triple integral that we can work with. Now, one of the things that we may take note of is I could do this. Notice the symmetry here on these last two integrals. I could change these to go from z squared to 1, and then over here 4 to 4 minus z, and just double it. In other words, what if I just integrate this bottom part and then double it? Because there's symmetry there on these last two integrals. So I could do that. And then I could go ahead and work through this. Now I'm integrating with respect to x first. So here I go. I've got negative 1 to 1, z squared to 1. Now, as far as using symmetry, be very careful. Don't use symmetry unless you're absolutely certain that you can. So, watch yourself. So now this is going to be 4 minus z x from 4 minus zx. Actually, let me put in that step. I've got x, 0 to 4 minus z, dy dz. Okay, there we go. Now I put in the x, and I get the integral, 2 times the integral from negative 1 to 1, the integral from z squared to 1, and then this is just going to be 4 minus z, dy dz. There we go. Okay. Now I'm going to integrate with respect to y, and here's what happens now. I've got negative 1 to 1. That doesn't change. But here I've got 4 minus z times y from z squared to 1, and then dz here. Okay. So let's see what this is going to be now. We've got 2, negative 1 to 1. This is going to be 4 minus z times 1 minus 4 minus z times z squared. And I'll put a dz here. There we go. Now we simplify this a little bit. So this is negative 1 to 1, and we've got 4 minus z minus 4z squared plus z cubed. dz. Okay, we're in the final stretch now. Here we go. This is going to be 2. Now I just start integrating. 4z minus 1/2 z squared minus 4/3 z cubed plus 1/4 z to the 4th. And we're going to go from negative 1 to 1. Okay. Almost done. Here we go. 2 times. Let me put in a 1. 4 minus 1/2 minus 4/3 plus 1/4 minus, put in a negative 1. Negative 4 minus 1/2 plus 4/3 plus 1/4. Okay? So that is when the z is negative 1. Okay, now let's see what we've got here. We've got 2 times, let me just combine these. I've got 4 minus 4. Ooh, 4 plus 4, isn't it? See, a minus and a minus. Then I've got negative 1/2 plus 1/2. I've got a negative 4/3 minus 4/3. And remember, I factored out the 2. And I've got a 1/4 minus 1/4. So I factored out the 2, and I hope I didn't mess up here, but I was kind of doing this in my head. I've got, I was trying to change the signs as I go. So hopefully we'll be okay. So now I've got 2 times, let me see here, 8 minus 8/3. Ooh, is that it? There's 8. This is 0. This is 8/3. And then this is 0. Okay, so let's see what we get here. We get 2 times 24 minus 8 over 3. Yeah, I think so. Okay, so let's see here. This is 2 over 3 times 16, and that's 32/3. Yeah, there it goes. Perfect. So the challenging part really is just figuring out how to set up these boundaries. That's what we need practice with.